You've probably heard of the birds and the bees, the story of how your parents made you and you grew in your mom's uterus, turning from a tiny little zygote to a weird-looking jelly bean to a fully formed baby. And you might have heard of how your sex was determined at conception thanks to your dad's genes. That is, whether you got 2 X chromosomes or 1 X chromosome from your mom and 1 Y chromosome from him. But did you know that this X and Y game is not how every other animal on Earth gets to be male or female? Indeed, some animals' sex is chosen by the environmental conditions during their fetal development. This is called environmental sex determination, or ESD, a mechanism in which an individual's sex is decided after conception, according to its immediate environment. In some reptile species, it is the temperature in which the eggs are developed in the nest that determines whether younglings will emerge as male or female. More specifically, we call this temperature-dependent sex determination, or TSD. Often, eggs incubated at low temperatures, from 22 to 27 degrees, produce one sex, whereas eggs incubated at higher temperatures, like 30 degrees and above, produce the other. There is only a small range of temperatures that permits both males and females to hatch from the same brood of eggs. For example, in the American alligators, if the eggs are incubated at higher temperatures, the hatchlings will be male, and vice versa. In the case of the green sea turtle, Colonia mitis, the embryo's sex is determined during the second third of incubation, where, the warmer the egg, the higher the probability of a female hatchling. However, because of climate change and global warming, species with TSD are at risk of having a biased sex ratio, a skewed proportion of males to females. In healthy species, the sex ratio should be approximately 50-50, but the shortage of one sex is considered quite dangerous from a biological perspective, as it is expected to lead to mate finding difficulties, failure to reproduce, and ultimately, population decline. For species who have TSD, the pivotal temperature is the temperature at which 50% of the hatchlings are females. Pivotal temperatures vary across species and between populations. For green sea turtles in Costa Rica, pivotal temperature could range between 20 and 30 degrees Celsius, while for green turtles from the southern Great Barrier Reef, the pivotal temperature is 27.6 degrees, and it is 29.3 degrees for populations in the northern Great Barrier Reef. Scientists have found that only a slight change in temperature can substantially alter the sex ratio of turtle hatchlings. Specifically, when the pivotal temperature is exceeded by only 1 degree Celsius, 80% of green sea turtle hatchlings in the northern Great Barrier Reef will hatch as females. The issue is that, with climate change, global mean temperatures are expected to increase by 1 degree up to 3.7 degrees Celsius until the year 2100. Therefore, whether or not the green sea turtle will survive climate change depends on their ability to adjust rapidly enough to the increasing temperatures and prevent extinction. Thankfully, there are multiple traits and behaviors that might evolve to counteract the negative effects of climate change. For example, species can shift their geographical range to colder locations, though this may be restricted by the availability of suitable habitat, seasonality, or other environmental factors. Interested in the question of green sea turtles' adaptations in the face of global warming, scientists modeled different populations through time with 4 possible evolutionary mechanisms: nest depth, pivotal temperature, level of shade, and beach orientation, as well as their combinations. They found that all mechanisms, except beach orientation, increased the average population size at the end of the simulation for both colder and warmer temperatures. And the most effective setup for survival at high temperatures was the combination of all 4 evolutionary mechanisms, though amongst the single mechanisms, nest depth promoted population survival the most. But there is an additional threat associated with climate change. As ocean waters push further and further onto shores, sea level rise could end up washing away sea turtle nesting sites in places like the United States, Australia, Costa Rica, and the Dominican Republic. Researchers estimated the probability of flooding under moderate and high greenhouse gas emission scenarios and found that nearly 3,000 sea turtle nest locations within 7 breeding grounds could be impacted between 2010 and 2100. Under a moderate emission scenario, breeding grounds located on flat beaches were the most vulnerable to flooding. But there is hope. A possible solution conservationists are considering is the relocation of nests to safer beaches. Of course, for this to be done properly, temperature and shade control measures need to be put in place to avoid high temperatures and to promote a healthy sex ratio. It is good to remember that sea turtles and their relatives have survived several climate fluctuations in the past. While the oldest turtle fossil records date back to the Triassic period, making turtles nearly 120 million years old, this time around it is up to us to ensure that the species will be able to keep up with the high pace of climate change. So the next time someone asks you about the birds and the bees, you should tell them about sea turtle eggs instead. Thanks for listening, and stay cool.